If you want to find the theory of everything but don't know where to begin, well, you're not alone. Neither do the physicists. All attempts to find the theory of everything have failed. But why? Because we are starting our searches in all the wrong places. Welcome to the instructional video series on hierarchy of energy theory, where all physics is united under one physical model. I am Scott Gordon, your host and creator of hierarchy of energy theory. In this introductory segment, I will show you the overlooked yet obvious starting point that leads us directly to the theory of everything. Over the past 100 years, physicists around the world have been relentlessly trying to find the theory of everything. At CERN, where we are finding more complicated particles, not more fundamental ones. At LIGO, where we measure waves in spacetime but have no clue as to what spacetime is. At our most prestigious universities, where physicists build on our current theories with no physical model that represents the math. And with all this money, time, and effort being spent, the prospects of finding the theory of everything remain absolutely dismal, to the point where some physicists are starting to think, there is no theory of everything. Over 10 years ago, theoretical physicist Michio Kaku made a prediction. He said, the theory of everything will be found. It will be represented by a 1-inch long equation, and it will come from a place you would never expect. Michio Kaku is right. The theory of everything has been found. Its essence is represented in a 1-inch long equation, and it is coming from a place you would never expect. And that place is me. You would expect the theory of everything to come from within physics academia, but when physicists ignore the obvious place to start looking, then it's left for someone outside of physics to lead the way. Physicists start with known equations using terms that represent distance and time with no concern as to how distance and time are created in the first place. Physicists propose additional dimensions with no concern as to how a dimension is created in the first place. But why is it a problem to advance our current theories to find the theory of everything? Because by advancing our mathematical models, we start at a point where we have already unwittingly bypassed the underlying foundation of physics with no concern as to what creates distance and time and dimensions. Physicists should not be taking these properties of spacetime for granted. We need a physical model of spacetime, not just its mathematical representation. The physical model of spacetime needs to show us exactly how distance, time, and spatial dimensions are created, while correlating with how they are mathematically represented in our current theories. I have to tell you a story, a very sad story, about the poster presentation I gave at the March 2025 American Physical Society meeting. The topic of the poster was the nature and structure of spacetime. A young PhD physicist walked up to my poster and within 2 seconds said, "This is all bullshit." After swallowing a little vomit that rushed into my throat, I took a deep breath and asked him if he knew how spacetime comes to have its properties of distance, time, and dimensions. He said to me, "That's an ignorant question." And I have to admit, I was very much taken aback. I thought in science there are no ignorant questions. And I couldn't help to think how the late, great Richard Feynman would have been horrified by this young PhD's statement, since it was he who famously said, "I would rather have questions that cannot be answered than answers that cannot be questioned." If you are one of those physicists who think that spacetime and its properties should be taken for granted, then this is not the video for you. However, if you are curious to see how spacetime is the key to finding the theory of everything, then congratulations, you will be among the first to truly understand how the universe works. Advancing our current math to find the theory of everything will fail every time. In order to succeed, we need to turn our attention to finding a physical model for spacetime. This is not a simple task because the properties of spacetime challenge our common sense, especially the property of why the speed of light is the same in all inertial reference frames. For those of you who are unfamiliar with this mind-boggling property, let me explain. If a pitcher throws a ball to a catcher at 100 miles per hour, the catcher will measure the speed of the ball at 100 miles per hour. If the catcher is running towards the pitcher at 50 miles per hour, then the catcher will measure the effective speed of the ball as 150 miles per hour. Now let's exchange the ball for a photon. If a pitcher shoots a photon at the catcher, the catcher will measure the photon speed at the speed of light. Now, if the catcher is running towards the pitcher at half the speed of light, then the catcher should measure the effective speed of the photon at 1.5 times the speed of light. But that's not what happens. The catcher measures the photon going at the speed of light. Einstein postulated this crazy idea that the speed of light is a constant and subsequently derived special relativity. And while his revelation turned out to be true, neither he nor anyone else had any idea of how it could be true or whether or not a medium was required for it to be true. To this very day, there is still no explanation as to why the speed of light is the same in all reference frames. If you ask a physicist, they will tell you it's a property of space-time. I may as well be asking my mother, who'd say, "Because I said so." Now that's not an answer. The fact that physicists are taking space-time for granted when contemplating solutions for a theory of everything is why they are doomed to fail. Just look at all these properties of space-time that are being taken for granted. Space-time has the property of distance. Space-time has the property of time. Space-time has the property of 3 spatial dimensions. Space-time is the stuff that light moves through. The speed in which light moves through space-time is a constant. Particles existing in space-time are associated with energy fields. Particles interact within the backdrop of space-time. Space-time can bend. The interaction of particles and the speed of light appear to be the same whether our laboratory is moving through space-time or not. This is a heck of a lot to take for granted, and by not taking these properties for granted, we give ourselves a humongous challenge in trying to conceive of a physical model of space-time that satisfies all these requirements, and at the same time give rise to the mathematical representation of these properties contained within our current theoretical framework. But really, when you really think about it, how could we think that a solution to the theory of everything would not include the nature of space-time and how it comes to have its properties? In conclusion of this segment, it is space-time that holds the key, and it's space-time that is the starting point we must use to finally find the theory of everything. In the next segment, we start on our journey to reveal the theory of everything as we dive into the internal physical structure of spacetime and show the mechanisms within this structure that gives rise to how spacetime comes to have its properties of distance, time, and dimensions. If you're curious about this novel approach to find the theory of everything, then click the like button below and subscribe to this channel so you can be notified when future lessons are released.